So they have told us, part A, write the equation for the ionization of methanoic acid in water. Ionization of methanoic acid in water. We have methanoic acid ionizing in water to give us methanoate ions plus hydrogen ions. Are we there? The second version of the equation, we can get methanoic acid, ionize it with water to form methanoate ions plus hydroxonium ions. Are we there? So those are the two ways in which we can write that, the equation of ionization of methanoic acid in water. Then they are saying write the expression for the dissociation constant Ka for methanoic what? Acid. Are we there? So the dissociation constant Ka for methanoic acid will be equal to the concentration of methanoate ions times the concentration of hydrogen ions divided by the concentration of methanoic acid. Are we there? Then they are saying the molar conductivities at infinite dilution of some electrolytes at 25 degrees Celsius are given below. The electrolyte, then its molar conductivity at infinite what? Dilution at 25 degrees what? Celsius. So part A, they are saying calculate the molar conductivity of methanoic acid at infinite dilution. Calculate the molar conductivity of methanoic acid at infinite dilution. So we are going to apply Pollack's law of independent migration of ions, and we shall say the molar conductivity of methanoic acid at infinite dilution will be equal to the molar conductivity of sodium methanoate plus the molar conductivity at infinite dilution of hydrochloric acid, then minus the molar conductivity at infinite dilution of sodium. Sodium what? Sodium chloride. Sodium chloride. Why? Because sodium methanoate has methanoate what? Ions. Then plus the hydrogen ions from what? Hydrochloric acid. Then minus the sodium chloride ions from sodium chloride. Are we there? So the molar conductivity at the finite dilution of methanoic acid will be equal to, that is 101.0 plus 397.8, then minus molar conductivity of sodium chloride at infinite dilution, which will be equal to 300 what? 385.8 per ohm centimeter squared per mole. Then the next question is saying the molar conductivity over 0.05 molar methanoic acid is 24.318 per mole per ohm centimeter squared at 25 degrees Celsius. Calculate the degree of ionization of methanoic acid. From our formula of conductimetry, Ka will be equal to concentration of the acid times degree of dissociation squared divided by 1. They wanted that degree of dissociation alpha, isn't it? So the degree of dissociation alpha will be equal to molar conductivity at concentration C divided by molar conductivity of methanoic acid at infinite dilution. So alpha will be equal to, that is 24.318 divided by 385.8, and alpha is equal to 0.0630. That is our degree of dissociation alpha. Then the constant, calculate the dissociation constant Ka and the pH of the acid at this concentration and temperature. So Ka double brand equals to C alpha squared divided by 1 minus alpha, where alpha is the degree of what? Dissociation. So the dissociation constant will be equal to 0.05 times alpha squared, which is 0.063 squared divided by 1 minus 0.063. .1179 exponent negative 4 per mole per dm cubed. Yes?
I thought the equation to be the one that minus alpha to be negative.
Don't take it to be negligible, because this value is very big to be negligible. We're saying if it is 0.0000 something, that is when we negligate it. Is it okay? But 2 decimal places, 3 decimal places, 4 decimal places, we shall not negligate this to be approximately what? 1, because the value is significant in that context. So lastly, the concentration, we need the pH, but we can get the concentration of hydrogen ions by saying degree of dissociation alpha times the concentration C. So this will be equal to 0.063 times the concentration of the acid, which is 0.05. What is the answer? What is the concentration of hydrogen ions? 3.15 exponent negative 3. That is moles per liter. Then absolutely our pH, that's part of the question. pH will be equal to negative log concentration of hydrogen ions, which will be equal to negative log into 3.15 exponent negative 3. What is the pH? 2.5 is the pH of our acid.